Okay, we're continuing our discussion of different levels of competitiveness in product markets. So we started by talking about pure competition, and in the last chapter we did pure monopolies, which is just one single firm producing a product. But then we also went to monopolistic competition, which was actually close to the competitive end of things. But these individual firms, these small firms, had some degree of market power, and usually they do this by trying to convince their consumers, their customers, that their product is unique in a particular way. And so that even though the products that they are producing have a lot of decent substitutes for them, customers feel like, well, this company's product is a little different from all the rest. And so, again, we ended with that sort of discussion, but there was one more category, theoretical category, that we could consider, and that's what we're going to do in this chapter, oligopolies. They'll be closer to the monopoly end, so there'll be a relatively small number of these firms, and this small number means that each individual firm is going to be fairly large in size, but they're going to have some pretty distinct characteristics. We were able to come up with some pretty easy rules of thumb about how purely competitive firms behave, how monopolistically competitive firms behaved, and how monopolies behaved. Some easy rules of thumb: price equal marginal cost, marginal revenue equals marginal cost, figuring out where the individual price is situated relative to the average total cost curves, average variable cost curves, the shutdown decisions, all that good stuff. A lot of that was consistent in the previous two chapters. Here it's going to be a lot of that's going to get thrown out the window somewhat, because these individual firms are large enough in size and such a small number of them that they kind of all know each other. And if one firm does one thing, then it impacts the abilities of other firms to react. So we'll see how that plays out. So again, we're going to discuss a little bit about how these oligopoly markets behave. The key point is that the decisions that these firms make are interdependent. When you had a monopoly, then there was no other firm to worry about. You were the only game in town, so you made these decisions independent. The price and quantity that you picked were independent of anyone else, any other firm, because there were no competing firms. When you were in pure competition, there was lots of competing firms, but you just made your own decision yourself about how much output to produce, and that was based on where your cost curves were, where your marginal cost line intersected that market price. In the monopolistically competitive firms, again, even though there were a large number of firms out there, each individual firm made an independent decision. They looked at where their demand and marginal revenue curves were. They looked at what their marginal cost curve was to pick their output and their price. And so it didn't really matter what the other companies were doing. It didn't matter what prices they were charging or how much output they were producing. You just made your decision independently of them. In the oligopoly situation, though, because, again, the firms kind of know each other and they can observe what the others are doing, and there's not that many of them, if one firm tries to set a low price, well, that's going to pull a lot of customers away from me. And our firm may want to do something to protect ourselves from that. So there's this interdependence, this interplay between the different oligopoly firms. This will affect not only the prices they're going to charge and the amounts they're going to sell, but their profitability too. So again, the number of firms is small enough that every firm's price and output decision affects not only their own demand and marginal revenue situation, but that of every other firm that's out there. So we start making these strategic decisions, and these firms, instead of, again, employing these straightforward rules of thumb about, okay, setting marginal revenue equal marginal cost, you can't really do that anymore, because if you decide to set marginal revenue equal marginal cost and be profit maximizing, well, maybe your rival responds in such a way that they undercut you, and suddenly what you thought was profit maximizing before is not really going to help you out anymore. It's not going to be your optimal situation. So you can't just follow these simple rules of thumb. So businesses start taking these responses of their competitors into account, and they start devising these strategies about how best to respond to their decisions and the reactions that their competing firms have. And out of this, actually, this idea of game theory has been used to study these strategic decisions made by individual firms. It actually grew out of analysis of the United States and the Soviet Union in the Cold War, figuring out how, you had these two big superpowers playing off each other. One of them would do one thing, invent one sort of weapon system. The other country would do something else to counter that. And so the idea of game theory grew out of that desire to analyze how these two countries would sort of compete against one another. And again, you can see somewhat of the way that it led into the analysis of businesses in somewhat similar situations, hopefully without any weapons involved, though. And so again, this idea of game theory is just studying strategic behavior, basically, when there's this issue of interdependency that exists. And we're going to start by looking at what are called simultaneous decisions. So these businesses have to make price and output decisions, and we're going to say that there's a small number of them, But we'll start by making it simple and just say that each firm makes these decisions at the same time. So they make it simultaneously. And later on, we're going to look at situations where the decisions are made sequentially, where one firm will make one decision and then another firm is able to observe that and make their decision in response to what the first firm did. But here they're going to make these decisions simultaneously. Because they're all making their decisions at the same time, you don't really know what your rival is going to do. You don't know what choice they've actually made. You certainly may know the different payoffs they face and the different outcomes that might occur, but you don't actually know what they've decided to do at the moment. In discussing the different ways of how these firms behave, again, you look at strategies, and some strategies are better than others. And so there's one type of strategy called a dominant strategy. And as the name suggests, this means that this strategy is going to give you the best outcome no matter what decision your rival might make. So if we make this choice, it's always going to give us the best outcome. It doesn't matter what our rival does. And if you have one of these, if one of your strategies is a dominant strategy, then you don't really need to consider anything else. There's no other option really that your company would choose. But that also means that your rival might know that, or probably does know that. If your rival knows that you have a dominant strategy, then they don't really have to consider that you will make any other decision. So again, when one exists, the rational decision maker always follows its dominant strategy. And again, everyone else in the situation knows that too. So if you know that your rival has a dominant strategy, then you know that's the one they're going to follow. If there is one. There's not always going to be a dominant strategy. But if there is, again, then you would know that you, if you had one, would follow it. And if your rival had one, you knew that you would know that your rival would follow it. And we can talk about an equilibrium situation. We had equilibriums before in previous chapters. We talked about where supply equals demand, things like that. One other notion of the concept of equilibria is that they're stable. When you're at an equilibrium, if nothing else changes, then the market's going to sort of situate there and just kind of sit there for a while until one of the curves changes. And so that second idea about equilibriums being just sort of a stable endpoint will kind of carry through into this idea of game theory. And again, this will happen if every firm has a dominant strategy, then really that means that every firm only has one strategy. It's very likely that the situation is going to kind of settle into one single place. A popular type of game, I guess, that economists study when they're looking at these things is what's called the prisoner's dilemma. And we'll talk about it in terms of prisoners, but we'll see the business application in a second. And in this situation, every firm has a dominant strategy. Sorry, every convict, I guess, or potential convict, has a dominant strategy. What's unique about the prisoner's dilemma is that the dominant strategy, the one that each firm is going to pick, is not the one that is best for that individual firm. It's not going to lead to the absolute best outcome. So you can have this weird situation where you have an equilibrium where you know what the end result is going to be, but that end result is not the best for the individual firms. It's kind of a weird thing. So let's look at our two prisoners here, Bill and Jane, and the backstory, I guess. There's a crime that takes place, and the cops haul in Bill and Jane, and they presume that they're kind of in cahoots, working with one another to commit this crime. They don't have a heck of a lot of evidence to convict them both. They put them in separate cells, first of all. So Bill and Jane are sitting in separate cells. There's no way for the two of them to communicate with one another. And they tell them the story. Well, Bill, we kind of have a sense that you and Jane did this thing together. We don't have a whole lot of evidence to convict you both, but I tell you what, if you rat out Jane, if you confess, then we'll put you on some lesser charge, and we'll put Jane away for a long time. And of course, then the cops go to Jane and tell her the exact same story. They say, look, Jane, we don't have enough evidence to convict you on this big crime, but we have enough for kind of a lesser crime that we noticed you guys did. And so if you confess and say that you and Bill did it, then we'll give you a little bit of leniency, and you don't have to go to jail as long, and we're going to put Bill away for a long time. Clearly, since they don't have enough evidence to convict them both, it would be best if both of them did not confess. But let's look at the little payoff matrix. And the way that we're going to describe how Bill is going to do is Bill is going to be in kind of the brown italicized text. And Bill has these two options. He can not confess, or he can confess. And of course, Jane has sort of the same situation too. She can choose to not confess or to confess. Look at the different payoffs that occur. So let's think about if Bill and Jane don't confess, both of them. So we're in box A. Well, if they both don't confess, then you can see that Jane, the black bold font, would go to jail for 2 years, and Bill would too. So it's kind of, again, a smaller charge. If both of them decide to confess, then the cops say, well, we both know they both did it. And so Jane would go to jail for 6 years, and Bill would go to jail for 6 years, and that would be in box D. But what if them confesses and the other one doesn't? So let's say that Jane decides to fess up, and Bill doesn't. So, well, Jane confesses, and she gets kind of the plea bargain. She gets, only 1 year in jail, whereas Bill has to go to jail for 12 years, because, again, she ratted him out. So Bill goes to jail for 12 years here in box C. What if Bill confesses and Jane doesn't say anything? Well, then you get the flip side. Jane didn't confess. She goes to jail for 12 years. Bill gets the agreement from the cops and only goes to jail for 1 year. Okay. Well, if you look at the total amount of time spent in prison among both our suspects, the best situation in terms of total jail time is in box A, because there's only 4 years of total jail time here. So if they both don't say anything, then that's best for them both combined. So like I said, the best combined outcome is there in box A. But, okay, what does Jane think? If Jane thinks that Bill won't confess, then Jane says, really, this is what I know Bill's going to do. If I'm thinking he's going to stay here, then really Jane's options are, do I want to be in box A or do I want to be in box C? Which means, do I want to go to jail for 2 years or do I want to go to jail for 1 year? Of course, she's going to say, well, I'd rather pick the confess route. I'd rather be in box C rather than box A. Okay, well, if Jane thinks that Bill will confess, then Jane thinks, okay, we're on this side, so now I'm considering between box B and box D. Well, would I rather go to jail for 12 years or would I rather go to jail for 6 years? Obviously, she would rather go for only 6 years, and she'd be in box D again. Her dominant strategy is to confess. There's never any option where she feels like don't confess is the best choice. She always says confess is the best choice, to be in either box C or box D. Well, what is Bill's situation too? If we think about Bill too, Bill's has the exact same payoffs, and so Bill's going to have the same strategy. Bill's dominant strategy is to confess. If he thinks that Jane is not going to confess, then would he rather go to jail for 2 years or 1? Obviously, he'd rather be here in box B. If he thinks that Jane is going to confess, would he rather go to jail for 12 years or for 6? Obviously for 6. They both decide to confess, and they end up where? In box D, which is 12 years of prison for both, instead of 4 years in box A. So this equilibrium outcome, the outcome that will occur, is that both Jane and Bill will confess, and they'll be in box D, which is clearly worse than if they were to both to not say anything. So you get this situation where if they were to observe each other's situation, and if they were to take the other person's situation into account, they would probably both try to stay in box A. But individually, they don't face that incentive. Individually, they both have a better incentive to confess. And so they both end up in box D, which is the worst outcome compared to box A. Okay, so that's the idea of dominant strategies. If you have a dominant strategy, then you're always going to pick that. There's another kind of thing called a dominated strategy. Other types of strategies may be dominated. And again, this might be self-explanatory. This would never be an option that would be chosen. In the previous example, the don't confess route would be dominated because it was never the best choice for either of our suspects. And if that's the case, then you don't really have to worry about dominated strategies anymore. You can just get rid of them. Because sometimes a dominant strategy may not be clear at first glance, but you might be able to get rid of dominated strategies until you're able to figure out what your best choice should be. So let's say we have a situation here of 2, I think this is pizza places. And so again, we'll have Palace here is going to be our brown italicized font. And so there'll be kind of the right-hand payoffs in our little matrix here. Castle will be the black bold font. And they'll be in the left-hand payoffs of these different boxes. And so, okay, all you have to do is really just kind of go step by step and figure out what the best options for these different places will be. If we think about it from Castle's perspective, Castle says, well, hey, what if Palace charges high? What should we do? Well, if Palace charges high, then you're considering box A, D, and G. And you say, which payoff would Castle prefer? Well, they'd obviously prefer here at 1200. Okay. Well, if Palace charges medium, then which payoff or which price would Castle choose? Castle would rather be in box B instead of E or H and get $900. If Palace charges low, then Castle says, well, I'd rather also choose high, a high price, and be in box C. There was a situation where Castle would charge a low price if Palace charged high, and there were two situations where Castle would charge high if Palace charged medium or low. But you can see there was never a situation where Castle thought that the medium price was the best. And so we could say that there really isn't a dominant strategy for Castle at this point. There was no single price that stood out. But we can certainly get rid of the medium option. That was a dominated strategy for Castle. Castle would never pick that. Okay, we'll think about it from Palace's perspective. Palace says, what if Castle charges high? Then does Palace want to be in box A, B, or C? Well, they'd rather get $1,200 instead of $1,100 or $1,000, and so be in box C, charging low. Even though Castle's never going to charge medium, we can just, for example's sake, we can figure out what they would do. Let's say that Castle charged medium for some odd reason. Then Palace would charge a medium price also to get $800 instead of $400 or $500. Box E instead of D or F. And then, what if Castle charged low? What would Palace do? Well, Palace would choose the low price and box I, get $400 instead of $350 or $300 in boxes H or G. So again, from Palace's perspective, there's no dominant strategy. There's no one price that's picked all the time because, well, sometimes it's medium, sometimes it's low, but you can see that there is a dominated strategy because Palace never chooses high. So you can see that we get rid of quite a few boxes. Box A, D, E, F, and G are never going to be picked by either of these sides. And so then basically all you're left with is box B, C, H, and I. Those are the only boxes that are kind of in play at this point. So we can kind of reduce this payoff matrix and just consider box B, C, H, and I because the other boxes would never be picked. And then just do sort of the same steps. Well, if Palace were to charge a medium price now, then what would Castle want to do? So that's picking between box B or H. Well, Castle would obviously prefer $900 instead of $500 and choose high. What if Palace charges a low price? What would Castle want to do? Well, they'd rather get $500 instead of $400 and be back at the high price again. So here you can kind of see that Castle has a dominant strategy once we got rid of those other boxes. They have a dominant strategy of charging high, I guess a dominated strategy of charging low at this point. So what would Palace want to do? Well, if Castle charges high, then where would Palace rather be? Well, they'd rather be in box C, get $1,200 instead of $1,100. If Castle charges low, where would Palace rather be? $400 instead of $350. And you can see again, there's only one spot where both of them feel like it's the best place to end up. They're in box C. So you have this unique solution, kind of like the way we had the confess option before. So you saw that we had that unique solution from before, and we can give it a name of this Nash equilibrium. And a Nash equilibrium occurs where you know that everyone's kind of picking their best choice. The set of actions or decisions where everybody's picking their best actions given what they know everyone else is going to do, given their rivals' expected actions. Nash equilibria are stable. There's this sort of strategic stability. Once you're at the Nash equilibrium, there's no reason why any firm would deviate from that or choose some other option. So there's no way that any firm could make itself better by picking some other decision. Mostly because they know that if they try to deviate somewhat, then the other firm is going to respond and you would move back. So kind of the same way with if both of them knew that they would confess, then there's really no reason why either of them would suddenly choose to not confess. Okay, so some Super Bowl advertising, Coke and Pepsi. Do the steps, figure out if Pepsi were to do a low budget, what would Coke do? Well, they would rather get $60 instead of $50 or $45. So out of box A, D, and G, Coke would rather choose A. If Coke thought that Pepsi was charging a medium budget, or was going to advertise at a medium budget, then Coke says, well, we're choosing between box B, E, and H, choosing low, medium, or high budget. And so they'd rather pick box E. And if Coke says, well, what if Pepsi does high? Then we're picking between box C, F, and I. And Coke would say, well, we'd rather go high budget if Pepsi's charging high and be in box I. Pepsi says, well, what if Coke does low? What would we rather do? Would we rather have $45, $50, or $35? Well, they say we'd rather have $50 and be in box B. If Coke does a medium budget, then what should Pepsi do? Well, they're looking between D, E, and F, and they would rather be in box D. If Coke chose a high budget, what should Pepsi do? Well, they'd rather do a high budget also. And so again, you get this situation where box I is the only place where you have both of them kind of deciding on that. One of the things that I struggled with a bit when looking at this table is to say, well, what if I started out here in box A, where Coke's getting 60, Pepsi's getting 45. If Pepsi saw this, if Pepsi was like, well, here, both of us are doing a low budget, Pepsi's going to change. Pepsi's going to say, well, let's bump our budget up to medium to get $50 instead of $45. So then we'd be in box B. Well, then what would Coke do? Well, Coke would say, well, I'd rather go into box E and get $65 instead of $57.50. And then if we're in box E, then Pepsi would say, okay, well, I'd rather get $35 instead of $30. And so Pepsi would bump back down to low. And Coke would say, okay, well, if we're a medium, then if we bump our budget down to low also, then we'll get $60 again. And it kind of seemed like you would be just sort of continually moving in this circular direction without any sort of stable decision. Again, the concept of a Nash equilibrium implies some stability into the outcome that's going to happen. And if we're in this kind of this A, B, E, D cycle, there is no stability to that. No firm would feel like any of these options is good because the rival's always going to make some deviation, some change. The only place where the stability occurs is down there in box I. So we call that a Nash equilibrium. And again, it may not have been the best outcome. If you look at box I, the total payoff is $90. But if you just go up to box E, you can see the total payoff is $95. Or if you go up to box A, you can see the total payoff is $105. So again, just because there's a Nash equilibrium doesn't mean that it's the best outcome for both companies combined. Because again, box I is not the best outcome of all the boxes in this table. It's just the one that is going to happen. So this concept of a Nash equilibrium, when one does occur, then you can realize that the rivals are going to basically make the decisions that get themselves there, since they know this is the stable outcome, the outcome that's going to result in no deviations from that place, and again, no situation where, hey, we can, now that we're at the Nash equilibrium, can we do better than what we're doing? Well, the answer to that would be no. So again, everyone can be expected to make the decisions that get themselves there. You can have situations of multiple equilibria, multiple Nash equilibria. Since there's a multiple of them, then it's not easy to figure out what the outcome is going to be. I mean, if this was a game theory class, then maybe we could go into some of those details, but since it's not, I say that's good enough. There's kind of a handy graphical way of describing the results that may occur from these different Nash equilibrium games, called these best response curves. And again, these are going to be used for these continuous choices. So setting prices is more of a continuous variable because you can charge $10, or you can charge $10.01, $10.02, $9.98, things like that. If it's something about the, setting a high price or a low price, well, that's kind of a discrete choice between just two options. But these best response curves will be better for these more continuous choices like that. What they're going to show are all of the Nash equilibrium that exist between the different situations, the different prices that these firms can charge. So let's think about two different airlines, Aero Airlines and Bravo Airways. Let's say that you have two different demand curves, different demand functions up here. And you can see that the demand for Aero, the quantity of ticket sales for Aero, depends not just on its own price, but on the price that Bravo is charging. So its demand equation has this PB term in it. And same thing down here for Bravo's demand function. It depends certainly on its own price, but it also depends on the price that Aero is charging. And you might note also that the coefficient for both of those is positive, as we would expect. If Bravo charges a higher price, then that would lead to a higher ticket sales for Aero. Aero believes that Bravo's price is going to be $100. We can shorten the demand equation, the QA equation up there, by plugging in $100 in for the price of B, for PB. And so if you reduce that, I cut out some algebra steps, but you would have your 4,000 minus 25 times PA plus 12 times 100. So that would be 4,000 minus 25 PA plus 1,200. You can get 5,200 minus 25 PA. And after a little bit of rearranging, you get this PA equation. And out of that, you can get a marginal revenue equation fairly easily, taking a derivative. You can get your demand function, your demand curve, your marginal revenue curve. And if we just make this assumption that there's this constant marginal cost of $160, then you can see the choice that Aero would make. They would sell 600 units. They would charge a price of $184. So down in panel B, I've got Aero's price on the vertical axis, and I have Bravo's price on the horizontal axis. Aero believed that Bravo's price was going to be $100. And when PB was 100, we saw that PA was 184. That was the optimal price when Bravo's price was $100. Aero's best response was to charge 184. And so that's 1 point on our best response curve. But what if Aero believes that Bravo's price will be $200? Well, you go back and you kind of do all the equations over again. 400 minus 25 PA plus 12 times $200 now. and you'll get a different demand curve, different marginal revenue curve, and equations too. If that marginal cost for Arrow is still $160, you'll get a different price out of that. You get a price of $208 when Bravo's price was $200. And so if I just connect those two lines, of course points R and S are optimal choices for Arrow, but every point in between is going to be also. And again, if you maybe played around with a PB of $150, you could see what Arrow would do out of that. And I'm sure it would be some price that's the average of 208 and 184. Okay, so all of that was kind of done from Arrow's perspective, though. Arrow was considering the different prices that Bravo would charge, and we really only used that QA equation at top. If you just repeat the example from Bravo's perspective, where we had the QB equation equaling something else, then you plug in different possible prices for Arrow to charge, then you would get Bravo's best response curve. You see the BR there. BR doesn't mean Bravo, it means best response. So BRA is Arrow's best response curve. BRB is Bravo's best response curve. So you can see those two curves there. And as you might expect, the expected outcome, the Nash equilibrium, would be the intersection of those two, because that would mean that both firms are on their best response, or having their best response to what the other firm is doing. So there's this Nash equilibrium at point N. And again, you could conceive of these other situations that may be more profitable, but they're not going to be stable. Just like the Coke and Pepsi example, there are other situations where both firms would come out better, where they would earn more total profit, but those weren't stable. The only stable outcome was that box I, if I recall, even though that earned less profit for both companies combined. So the same thing here. Okay, so those were all simultaneous decisions. Neither firm kind of knew what the other firm would do at first. They knew what the payoffs were. They knew the payoffs that would result from these different options, but they both had to kind of make their decisions at the exact same time. There was no way to respond to what one firm had already done, because you're making decisions at the same time. Well, not all situations in business are like that. Sometimes a firm has already made its decision, and you can respond. So we call those sequential decisions. One firm makes its decision first, then the rival, knowing exactly what you've done, can make a response. But of course, this means that the decision I make today depends not only on what my rivals did in the past, but I know that they're going to respond to what I do today. Tomorrow, they're going to make a decision based on what I do today. So the sequential decision, solving for them, figuring out the best thing to do, is going to require a bit of predict the future. But if you can figure out what the payoffs are, then you can make these predictions. You can make those decisions fairly accurately. The way you do that is by using a game tree. We just describe them as game trees because they can look like plants, I guess. Different ways of showing the sequential decisions. When we had the prisoner's dilemma stuff, we had this little matrix box, and here we're moving to the sequential decision where it turns into a tree. We don't have the box anymore. One of the fun things about studying oligopolies is all the different ways of analyzing them. So it's not just a simple, hey, you got your demand marginal revenue curve and figure it out, and it's always the same, whether it's pure monopoly, pure competition. No, oligopolies, you have lots of weird different ways of sketching out the situation and seeing how companies are going to respond. So we had this little game tree thing, and you make these different decisions at these different nodes, and the sequence through time kind of goes from left to right. I mean, the leftmost decision is the earliest decision, the rightmost decision is the latest, or the furthest away decision. But the way you solve this thing is actually to go backwards, to figure out how people are going to respond in the future, and kind of back up to figuring out, well, okay, so what does that mean we should do today? So here we have these two pizza places again, Castle and Palace. Here's our game tree. And Castle has this first option, so Castle kind of makes the first move and says, well, do we want to charge a high price or a low price for our pizza? So that's the first choice that's made is Castle's choice. Palace makes this second decision. If Castle were to charge high, Palace says, okay, what do we want to do? Do we want to charge a high price or do we want to charge a low price? If Castle charges a low price, Palace has the same option. Do we want to charge a high price or a low price? So Castle's trying to figure out, well, what should we do now? Should we charge a high price now or should we charge a low price now? And it knows that there's this sort of second round of decisions that's going to happen, second round of decisions that Palace is going to make, and these resulting payoffs that are going to occur from that. So Castle works backwards and says, okay, well, what if we were to charge a high price? Look at these two payoffs that we're considering. If we were to charge a high price, then Palace makes this choice at option 2, and Palace would choose between earning $1,000 or earning $1,200. And which would they choose? Well, clearly they would choose the $6 option. charging a low price to try to get $1,200 of profit instead of $1,000. Well, what if Castle charged low? Then what would Palace do? Well, Palace would rather get $400 instead of $300 and be on that low path again. So Castle knows that Palace is going to charge low if it charges high, and Castle is going to charge low if it charges low. So then Castle basically is looking at, well, do we want to earn $500 or $400? Well, they'd rather earn $500, and so that means that Castle, even though it makes this first decision, it knows that it wants to charge a high price. And you end up in this situation here. We can figure out that the best strategy is going to be for Castle to charge a high price and Palace charging a low price after that. So again, we've kind of solved this by looking backwards, figuring out what would Palace do in response to these different Castle decisions. And that told Castle what to choose. Well, at this point, I know what you're thinking. You're thinking, why would Bill and Jane not both decide to don't confess? Why wouldn't they kind of work together and decide to not confess? They wouldn't go to jail for that long. Or why wouldn't Coke and Pepsi decide to both do that low budget? Because that gave them the $105 of total payoff. Why don't they just cooperate? And it's possible that they can, sure. So cooperation in our scenarios here would be when these oligopoly firms make these individual decisions that would make everybody better off. And this occurs, or this would occur, in a situation where there would be this Nash equilibrium that they're trying to avoid. So we knew the Nash equilibrium would be for both of our suspects to confess if they were behaving individually. But if they could cooperate with one another, they could avoid that Nash equilibrium. They could agree to the knowledge that, well, the confess option is dominated. If no one picks that, then we're going to be in the don't confess option. That'll be the best for both of us. They have to kind of fight their own incentives, I guess. But they realize that if they work together, then again, you can get this cooperative best outcome. The problem with that, and you may think that might happen a lot, these businesses would cooperate. That sounds like a nice word. In antitrust circles, you could say collude, I guess. These businesses colluding with one another. Coke and Pepsi decided to each keep their advertising budgets low. So that, everyone knows who Coke and Pepsi is, and if they don't sit there and knock each other out trying to one-up each other in their advertising budgets, then they keep their budgets low and they make a ton of money off of it. Why don't they just do that? Why don't they just cooperate all the time? Why don't these different oligopoly firms cooperate and just make a bunch of profit off of everybody? Well, because there's always this incentive to cheat. And then, of course, if you cheat, you make non-cooperative decisions. You do something your other companies don't like. Cheating can still occur even if there isn't some sort of handshake agreement. The prisoner's dilemma that we did before, the reason they cheat, presumably, is that, well, the other person goes to jail for what they think is 12 years, even though it ends up they both end up going to jail for 6 years. But they probably feel like, well, Bill and Jane, Bill says, oh, well, I don't feel like doing any more criminal activity with Jane anymore because we got caught, and Jane kind of says the same thing. So if they feel like they're never going to see each other again, then, of course, there's this option to just rat the other person out. And so in that one-time prisoner's dilemma game, then the cooperate strategy is not strategically stable. They realize that, again, it's better to confess than to not confess. If they do that, of course, then Bill is in jail for 12 years and Jane doesn't have to worry about seeing him later on, and vice versa. So in this one-time games, there's no future consequences from cheating. And so you just expect the other side's going to cheat. Cheating ends up being this best response for both parties. And again, for a lot of what we might consider to be cartels or collusive agreements between different firms, the presumption might be that there's going to be all sorts of this cooperative behavior and these backroom deals where these businesses are working with one another. But again, there's this very, very big incentive to cheat, and it's pretty easy to do. And again, there's a big payoff if you can do it. And so again, that might sound like a weird thing that we expect cheating to happen a lot, but if you're looking at it from the kind of the consumer's perspective, then that's kind of good that these different firms, instead of working together to extract a big profit from their customers, it'd be kind of nice if they cheat, because that means that one of them is setting a low price and undercutting all the rest. So let's look at AMD and Intel, and again, this is kind of a prisoner's dilemma adaptation for these different businesses and the kind of prices they may charge. Same sort of discussion that we had before, though. Let's say Intel considers if AMD were to charge a high price, and Intel's trying to decide, should we do high or low? Do we want to be in box A or C? And of course, Intel says we would rather be in box C if AMD is going to charge high. Well, what if AMD charges low? Where would Intel rather be? Earning $3 or $2 in box B or D? Well, they'd rather be in box D. AMD does the same thing. If Intel charges high, would we rather be in box A or B? Well, they'd rather earn $3 instead of $2.50, be in box B. If Intel charges low, what would AMD want to do? Would it rather earn $1 or 50 cents? And rather be in box D. So again, you see this Nash equilibrium outcome in box D with the total payoff of only $4. Look at the payoff in box A, though. Again, the total payoff would be $7.50, which is almost double what the payoff would be in the non-cooperate outcome. Again, if they were able to cooperate with one another and be in box A, that would be great. They'd earn this $7.50 profit, and maybe they could split it between them or something. But, of course, individually, they both have this incentive to cheat. And since they both have this incentive to cheat, they're going to end up in box D. And especially if there's not an expectation that they're going to see each other in the future and have to deal with one another in the future. If there is kind of a collusive agreement, backroom deals, and if one of the companies decides to cheat and try to get a one-up on the rest of the firms in the agreement, then the other firm may punish that rival firm for cheating. And there's different ways that punishments can happen. Usually this is going to occur if there's repeated decisions, not just a one-time choice, but if you're able to encounter this rival or this other firm again, then you could try to punish that cheater. So if Bill and Jane ever saw each other again, and Bill confessed and Jane didn't, then Jane may try to beat Bill up or something like that. So if you encounter your rival again, then you can try to punish some cheating that may have occurred earlier. If you're trying to decide whether to cooperate or not, and there's different payoffs to those, present value of future costs and benefits. So if the present value of the future costs of cheating exceed the present value of the future benefits of cheating, then of course you decide to cooperate. And this occurs, of course, if all the businesses decide that it's best to not cheat. This will imply that they cooperate if they all agree together at once. If a firm decides to just look at its own situation, then it may decide to cheat. But if all of them decide not to cheat, then they cooperate. When do you cheat? Well, you cheat when the present value of cheating exceeds the present value of not cheating, or exceeds the present cost of cheating, present value of the cost of cheating. If you do decide to cheat, though, again, there's this issue of being punished for it in the future. Again, if it's a one-time thing, and maybe I guess you could see a situation where you have this agreement between these different firms, and one of them decides to cheat and set a low price. If that one-time decision puts every other business out of business, so it's just the cheater is left and all the other firms went bankrupt, then that'd kind of be a one-time decision. But, that doesn't really happen most of the time. There are situations where the other firms still stick around, and they may be able to punish the firm that cheated somehow. Two different descriptions, ways of doing this, and of course there's different variations besides just the two here. But you could have kind of a tit-for-tat strategy where maybe in one round or 1 month maybe, or 1 week, who knows, 1 year, the cheater decides to set a low price. In a tit-for-tat strategy, the other firms would say, well, you undercut us for a month, and so we're going to punish you for 1 month also. So you punish after an episode of cheating, and after that, you kind of return to cooperating again. You say, okay, hopefully you learned your lesson. Don't do that again. Don't undercut us for a month, because we're going to undercut you and punish you for a month. But, okay, now let's go back to the way things were. That's kind of a tit-for-tat strategy. Eye for an eye kind of thing. There's also the grim strategy, which is someone plucks out your eye, then you decimate their whole tribe. If the cheater cheats, then the punishment against that cheater continues forever, even if the firms decide to move back into the collusive arrangement again. Even if the cheater decides to come back to the agreement, the existing firms or the other firms may still decide to continue punishing that one rival. And so whether this actually happens or not, you might think that the grim strategy is just terrible, but it could be a good strategic move if you're going to set up an arrangement like this between different businesses. You could see why having this kind of a strategy or a punishment in the rules could encourage businesses to continue cooperating, because it has such a severe punishment for cheating. Even though you might not ever have to pull the trigger on this, having this grim strategy and kind of the rules or the contracts that every company follows, could be a good thing, a much better way of deterring cheating than the tit-for-tat strategy. There are different ways that collusion, or again, I guess it depends on the way you're thinking about it. Collusion kind of puts a bad spin on it. Cooperation sounds better. There are different legal ways that cooperation can occur. I guess there's other illegal ways that you could force the businesses to keep doing the same thing or to charging the same price. But there are other legal ways that make it easier for businesses to cooperate with one another. And the 4 that we'll talk about here, which we'll go into detail in a second, price matching, sale price guarantees, public pricing, price leadership. Again, these are all in the context of firms figuring out what prices to charge because they want to cooperate with one another. They want to avoid the both confess worst outcome. And so we got to figure out a way to make sure that everyone kind of charges the same price and keep this agreement going. So one way of doing it is this price matching. I'm sure as we discuss these things, you'll think about, oh yeah, I remember when I saw an advertisement or I saw a commercial for a company doing something like this. So price matching. The firm says that, hey, we're going to match any lower price that a rival is going to offer. We'll match it. And you might think, hey, that's great. This company is looking out for its customers. They're saying that if one of their competitors offers a lower price, then they're going to match it. And you might think that that's in the best interest of the customers, and maybe it is too. But you can also see another side of it, that it's going to discourage the other rivals, the other competitors, from cutting their prices, because they're not going to gain any customers by doing that. If Kroger decided to set a lower price, then Brookshire's would say, well, we're gonna match any lower price that Kroger's has. Then it really doesn't do Kroger any good to have a sale on something, because they're not going to pull any of the Brookshire's customers from them. So it discourages this non-cooperative cheating, this cheating version of price cutting. Because again, you might think that, well, the whole reason for doing this is you cut your price because you want to attract consumers. But if you know that, well, if we lower our price, all the other companies are going to lower their price too, then you're not going to gain new customers. So there's really no benefit, because you're selling your product at a lower price and you have the same number of customers you always had. So that would lower your profits. Another version is this sale price guarantee, where the company says, we're going to sell you this product at this price today, and if we ever have a sale on it in the future, then we're going to give you kind of a rebate for that. And of course, the reason that the organization of firms may decide to collectively do this, to agree to this, is because, again, it makes it very costly for a firm to cut its own price, because it's going to have to give all these people rebates. So again, it's a way of guaranteeing that the prices that are charged stay fairly stable. And again, it's only going to be useful if most of the firms offer them. If you have a company that doesn't offer this kind of sale price guarantee, then it's easier for them to avoid the situation than the rest of the cartel. When we look at this public pricing model, I always think of airlines, because it's very easy for me to look at different airfares for a particular route. So I assume not only is that easy for me to find out, but it's easy for all the other airlines to find out too. If I'm Southwest, I can easily see what Delta is charging for other routes, just like I can see what Delta and Southwest are charging. So this public pricing idea is the notion that, well, it's easy to figure out the different prices that are being charged, and it's easy to tell if one of the groups in this cartel, if they're lowering their price, if they're trying to cheat. It's easy to see that. Because I can just go to Hipmonk or Kayak or whatever, Travelocity, and I can see easily which companies are lowering their price. And again, this reduces the present value of the benefits of cheating, because everyone can see what you've done very easily within the same day, basically. And again, it increases the cost of cheating, because it's maybe trigger one of these punishment strategies. And that means, again, that there's not going to be these kinds of non-cooperative cheating price cuts. It's not going to happen. Last one that we'll talk about is this price leadership model. And this is a situation where you have one firm that kind of stands out from the rest. It doesn't necessarily have to be the biggest firm. It doesn't necessarily have to have any of those kinds of characteristics, but there may just be sort of this agreed upon firm that runs the show, that sets the price that all the others decide that they're going to follow. And again, it sets this price to make sure that the rest of the industry gets as much profit as possible. Not necessarily the price of that individual firm maximizes its profit, but it sets a price where the entire industry, or at least the entire collusive agreement, all the firms within that agreement, earn their maximum profit. And again, the rest of the firms say, okay, then we're going to charge the price that you do. You might think that this requires, and even the other ones too, you might think that it requires some kind of an explicit agreement to follow this kind of price leader model. You have to sit there and agree to who's the price leader. Not necessarily. In the price matching model, where it was, well, if one company has a sale, then we'll lower our price to match their price. Again, there doesn't have to be an explicit agreement between these two firms that, hey, if you lower our price, then we're going to lower our price too. It just kind of happens organically, I suppose. It's still a way for these businesses to cooperate, but there doesn't have to be this signed contract between the two businesses that achieves it. I mean, the antitrust laws basically look for these kind of backroom deals where there is this observable contract, this written contract that you can track down. But there are ways that businesses can cooperate that don't leave that kind of paper trail, that don't have this explicit agreement. And again, they generally tend to be lawful. I mean, how can you argue that it's bad for consumers to say, hey, we're going to match a price cut for a company, a rival? that's very good for consumers. If Kroger's has a lower price, then Berkshire says, hey, we're going to lower our price too. I don't see how consumers are harmed by that. Even though it may be a way of this sort of cooperative price fixing. Again, it benefits consumers just to have that strategy on its own, that policy on its own, is beneficial to consumers on its face. So these things generally tend to be lawful. We can talk about cartels, though, since I've kind of been using that terminology already. Cartels are going to be these explicit agreements where you have this agreement between these different firms to drive the price up, restrict output, improve profits for everybody. Of course, we don't have them here, at least you're not supposed to. We don't have them here, and most of the industrialized countries, they have rules against cartels. I always think it's funny because when you talk about cartels, then you can actually go to the OPEC website. And so there's this cartel. Obviously, there's agreement to push up prices of oil amongst these, this organization of petroleum exporting countries. These petroleum exporting countries just have this blatant cartel where they push prices up by restricting output. And it's just kind of funny that again, in the U.S., we think of these cartels as being these shady, illegal companies that are trying to fly below the police radar, and they're being really secretive. And there's OPEC, and they just have their website. You can go to their website and probably like it on Facebook and things like that. So, okay, these cartels have these pricing schemes that may be difficult to maintain. A lot of times, with most of the cartels that have existed, maybe excluding OPEC, a lot of the cartels that have existed throughout U.S. history, maybe, they don't really last that long. They're not maintained for a long period of time. And again, mostly because of this issue of cheating. So why don't we have cartels a lot? Well, because there's this huge benefit from cheating. And so these cartels may start, they may begin at some point, but they don't really last very long. They don't tend to last very long, historically speaking. And I guess there are these rules that the Justice Department has where they will allow the people who rat the other companies out. They'll give them a little bit more lenient sentence. So kind of a similar situation we had with the prisoner's dilemma thing. They won't prosecute the first person that exposes these price-fixing deals. And so again, that's a way of preventing these deals from beginning in the first place, or to help them to break down if they've already begun. And thinking about the cheating issue, how easy it is to detect cheating, I guess there's different ways. When we talked about the public pricing model, it can become really easy to detect when a company has cheated the collusive agreement. And so, well, what happens? Obviously, if you lower your price, if you decide to cheat, then you're expecting that you're going to lower your price and you're going to gain a lot of consumers from doing that. So if it's undetected, if you have a price cut that is undetected, then you're going to increase your sales a lot. You're operating in this very elastic portion where all these companies are selling a similar product. You lower your price. If it's undetected, if the other companies don't know that you've done this, then you can pull a lot of customers away from them. So when you do this, then your substitute becomes cheap. Get a lot of increase in your sales. So there's this lure of much greater revenues from cheating, which again is why a lot of firms cheat, which is why a lot of cartel arrangements don't last very long. If it's detected, though, if these cartel members can see what you're doing, then they'll match what you do. They'll match whatever price cuts you've done. And you're in this inelastic range of demand. We'll see what this means in a second. I mean, if you try to lower your price, but everyone else does too, then you don't really seem like that much of a better option. Hey, we lowered our price. Well, yeah, so did everyone else. In that situation, there's really no benefit to you of lowering your price because you don't gain that many customers from doing so. So let's look at Intel here. And Intel may be hypothetically part of this cartel selling these chips. And it says, okay, well, there's this demand curve where if the other companies don't see what we're doing, if they cannot detect what we're doing, then if we were to lower our price, we'd increase our sales a lot. But if the other companies did see what we were doing and they matched whatever price cut we did, then we wouldn't increase our sales very much. Demand would seem to be very inelastic because we could lower our price, but we would not increase our quantity demanded very much because all the other rivals are cutting their price too. So again, if they were currently charging a high price and they had this QA quantity of chips bought and sold, they might think, hey, let's lower our price. Let's lower our price and we can get out to point C because if they don't see what we're doing, if the other companies don't see what we're doing, then we can lower our price to peak low. We will be at point C on this undetected demand curve. And we could sell this QC number of chips. That's a huge increase in our sales. But what if all the other rivals can see what Intel is doing? Well, then they'd be at point D, because all the other rivals would say, well, we're not going to let you just lower your price and us stay the same. We're going to lower our price too. And you can see that Intel does increase the amount of chips that it would sell from QA to QD. It's not going to pull any sales from any of the other current chip manufacturers because they're lowering their price too. But it might actually cause some people to buy a chip that didn't buy one before. There are some customers who might have thought that this P high was too high, and they say, well, I don't want to buy a chip or a computer or whatever. It's too high, too expensive. If the price falls, though, it might actually draw more total customers into the market. And so Intel might be able to increase their sales a little bit just because it attracted some consumers who didn't want to buy anything at all before. But it's certainly not going to draw customers away from other chip manufacturers. So the only increase from QA to QD that's happening is pulling these people who didn't buy anything before into suddenly buying some now. But that's not a very big group. Okay, what are different ways that collusion can occur? Agreements between these businesses can occur. And we use this phrase tacit collusion. Tacit kind of means that it's sort of unspoken, it's difficult to detect. You can collude, firms can collude with one another without this sort of explicit agreement, without this kind of handshake, without this written contract. So there are ways that collusion can occur without it being very visible or without it being very detectable. One way is this strategic entry deterrence. If there's something that an established firm can do that prevents new businesses from starting up, then that's going to prevent, it's going to prevent new entrants from starting up and prevent new competitors from jumping into the industry. One way of doing this is called limit pricing, which is setting your price so low that it prevents new businesses from starting up. And I guess that the bare definition of it is just the existing firms set their price below their profit maximizing level. And you might wonder why businesses would do that. Why don't they just charge their profit maximizing price? Well, if they did that, it might encourage new entrants to come in. But if all of them set their price below their profit maximizing level, then a potential entrant might say, well, there's really no reason why we should jump in here because we'd have to set this low price too. And if we tried charging a high price, then we wouldn't get any customers. So if we jumped in, we'd have to set this low price too, and we might not be able to break even. And so there's really no point. What might happen if Star Coffee has this profit maximizing price of $4, but it also has this potential price of $3 that it can charge? And let's work backwards on our gain tree here. Again, Star Coffee says, should we charge a $3 price or a $4 price? Let's think about what Burned Bean's going to do. So if we charge a $3 price, Burned Bean would have to think about, well, do we want to earn negative $20 by entering, or do we want to earn $0 by staying out? Well, the best choice for Burned Bean in that case would be to earn $0 from staying out. If Star Coffee chose its profit maximizing price of $4, then again, what would Burned Bean do? Would it want to enter and earn 20, or would it want to stay out and, of course, earn 0? Well, now it's going to want to enter and earn 20. Okay, so then Star Coffee backs up and says, well, given that this will be the outcome up here, and given that this will be the outcome down here, then which should we pick? Do we want $60 or $40? Well, we'd rather have 60, which means if we back up, that the $3 price becomes optimal for Star Coffee. So you get two situations here, two things to note. The first is that Star Coffee picked its non-profit maximizing price, $3 price below its $4 profit maximizing price. It's not charging as high as it could. The other thing to notice is that it actually did deter Burned Bean from entering. Burned Bean is going to stay out if Star Coffee chooses its $3 option. Another more complicated path here. Let's look at these different outcomes. Let's look at point 3 first, because again, we want to work backwards. So let's look at point 3, and we'll start with this top one. So Star Coffee might consider a $3 price or a $3.50 price, and has this payoff of $38 and $35. This is kind of a 3-stage game, so we're back to Star Coffee responding to what Burned Bean does after Burned Bean responds to Star Coffee's first choice. So $3 or $3.50, well, $38 is better than $35. Okay, then we'll come down here to the point 3. Does Star Coffee want to do a $4 price or a $3.50 price? Earn $40 versus $50? Well, we would rather earn $50. Okay, so then we have to back up and go to step number 2 and figure out what Burned Bean wants to do. If Burned Bean stays out, clearly it earns 0. If Burned Bean enters, then it knows it's going to end up over here and earn 15. It would never get negative 20, because Burned Bean knows that if it were to enter, then Star Coffee would never pick this path. And so Burned Bean says, well, if we enter, we're going to end up over here. And so again, the comparison is, do we want to enter and earn 15, or do we want to stay out and earn 0? Obviously, we want to enter and earn 15. But we got to consider the other point number 2 and say again, do we want to enter or do we want to stay out? If we stay out, we earn nothing. If we enter, then we earn 15. Well, again, 15 is better than nothing. So then you go back to Star Coffee here and say, okay, I know that if we were to set a low price, then I'm going to keep following this path and earn $38. If we charge a high price, $4, then we're going to continue following this path and earn $50 of payoff. So which would they pick? Well, they'd rather earn that $50 of payoff. And it seems like I said, if they charge this $4 price, then what's going to happen? They don't always have to charge $4. They might charge $4 in that first round, or that first month, first week, whatever, and that gets them to here, and then Burn Bean makes this other choice. But what ended up happening, though, at least at round 3, was that Star Coffee charged a price below its equilibrium price. It charged $3.50 instead of $4. So it did have this limit. It also did not deter Burn Bean from entering. Burn Bean still entered. So again, this idea of limit price doesn't always imply that the rival is going to leave or the rival is going to stay out. Because in this case, Burn Bean was not deterred. It does mean, though, that Star Coffee did end up charging a price that was below its profit maximizing. Okay, another way that businesses may be able to deter new entrants from coming in is if they have this capacity expansion. And it's this threat that, well, if you new entrants come in here, then we're going to increase our size so big that we're going to be able to take advantage of these economies of scale, lower our costs, and you won't ever be able to compete with that. So it's threatening a price cut, not by saying we're going to cut our prices, but by saying we're going to increase our capacity so much that we're going to basically, again, enjoy these economies of scale, and we're effectively going to be able to reduce our costs, which will allow us to reduce our price. So it's another way of preventing new businesses from coming in. It's going to have to require that the existing firms are going to be able to actually do this for the threat to be credible. Okay, so let's think about this, again, these different trees. In this case, entry is not going to be deterred, and you have your Burn Bean, your Star Coffee. If Burn Bean enters, again, we're here at point 2, Star Coffee charging a $3 price, $4 price. Star Coffee would rather do the $4 thing. If we're down here at this point 2, $3 price, $4 price, Star Coffee would choose the $4 price. So what would Burn Bean want to do? If they entered, they would follow this path and earn $20. If they stayed out, they don't earn anything. So in this case, Burn Bean would choose to enter. Again, the payoffs may differ, though, where if we're here at Star Coffee again, $3 price, $4 price, $34 versus $31. Well, Star Coffee would rather charge this $3 price and be up here. Down at this point, too, $3 price, $4 price, $75 versus $55. Star Coffee would rather pick that. And so what does that make Burn Bean do? Well, they would rather stay out. And again, you can see the better payoff that Star Coffee gets by being able to expand so much, because keeping Burn Bean out leads to a much bigger payoff of $75 than if Burn Bean were to actually enter.